Yes, good morning, students. My name is Lakshmanarana. This is Ellen Grad of Chemistry. Yes, good morning. Come to the live session. Yes, come to the live session. Good morning. So, my name is Lakshmanarana. This is Ellen Brand of Chemistry. Today, we are going to discuss the remaining questions which are present in the Thermodynamics chapter. Remaining previous year questions that we are discussing. So, look at here. One of the question is that the delta H and delta S for a reaction are 30 kilojoules mole inverse and 0.06 kilojoules Kelvin inverse mole inverse at 1 atmospheric pressure, at which free energy change is equals to 0, and the nature of this reaction below this temperature is. So this is the question actually. Then look at the question carefully. The delta Z, that is free energy change, is equals to 0. Then the temperature, delta H and delta S, so free energy change, where the relation is there and which formula all these relations will be there. That is delta Z, it is equals to delta H minus T delta S. Then so free energy change is equals to 0, nothing but in the place of delta G, how to take it as 0. Then delta H minus T delta S. Then minus T delta S, when it is sent this side, T delta S, it is equals to delta H. Delta H is what? Change in the enthalpy. Delta S is what? Change in the entropy. So what is required? They're asking. The temperature is required. So at which temperature below, the nature of the gas, they're asking. Nature of the reaction, they're asking. So look at temperature equals to delta H divided by delta S. Delta H, what will be there, man? 30 kilojoules. So 30 kilojoules, nothing but 30, then into 1000, then 30,000 joules, 1000 joules, then mole inverse. Then next to this is 0.06 kilojoules Kelvin inverse mole inverse. Then when it is converted into the joules, then you can get it as a 60 joules Kelvin inverse, then mole inverse. We know that mole inverse cancel, right? Then joules cancel, right? Then 0 cancel, then 6, then here 500 you can get. So 500, the Kelvin inverse when it is set up, Kelvin. So temperature you can get 500 Kelvin, 500 Kelvin. So at 500 kelvins, the below this temperature, it is actually the non-spontaneous. So the nature of reaction is non-spontaneous. Sir, how can you say the non-spontaneous? How can you say the non-spontaneous? So remember, when the delta Z, it is equals to 0, reaction is present in the equilibrium position. Equilibrium. Then delta Z is positive. Delta Z is positive, non-spontaneous. Non-spontaneous. So delta Z, it is equals to negative, then spontaneous. Spontaneous. So then delta Z positive or negative? So positive, non-spontaneous. How can you say delta Z is positive? Delta Z positive and ela cheptavu. So look at in this formula. delta Z, it is equals to delta H value is given positive value, delta S value also is given positive value. So, but delta H value is a higher value, right? So that is 30 kilojoules. So 30,000 joules. So minus T at 500. So 500 into then 60 at this 60. Sir, below this temperature, actually this you can get 0. So below this temperature, temperature kante takkunte, sir, in case 400 is there, so 400 is there, then you can get, so 30,000 minus 24,000 you can get. So below this temperature, positive value you can get, right? Positive value you can get. So positive value, when delta Z value positive is there, then non-spontaneous reaction. Understand, my dear students? Whenever such type of questions are given, whenever they're asking the nature of reaction, either delta Z value is a positive or negative, that you have to find out. Delta Z value positive, non-spontaneous. Then delta Z value negative, spontaneous. Delta Z value is a 0, that is equilibrium. That you have to remember, my dear students. Yes, note the question, then we'll discuss. Look at the next question. Look at the next question. So look at the next question. That is, the enthalpies of formation of gases the enthalpies of formation of gaseous N2O and NO at 298 kelvins are 82 and 90 kilojoules. 82 and 90 kilojoules respectively. The enthalpy change, the enthalpy change of the reaction. This question is given in the 2023 May 12th adina question idi. Then for which reaction enthalpy change they're asking, N2O plus half O2 gives rise to 2NO. All these are gaseous reactions. Then options are given. So A is minus 74. Then B is plus 98. Then C is plus 89. Then D is minus 47 kilojoules. 47 kilojoules. So this is the question. Look at the question carefully first. Look at the question carefully. So what they're asking in the question? So enthalpy of formation of values are given. The enthalpy of formation of N2O and NO both are given. Then one of the reaction is also mentioned. Sir, what is the enthalpy change in the particular reaction? They're asking question. Yes, observe the question carefully. Observe the question carefully. So enthalpy change for the reaction. Enthalpy change for the reaction. So for this reaction, so these are the NO that are products, then these are the reactants. Then in case enthalpy change of reaction, if you want to find out, enthalpies of products minus enthalpies of reactants have to take. Enthalpies of products minus enthalpies of reactants have to take. The enthalpy change for the reaction is the asking question. So look at here, enthalpies of products. Products, how many are there? So 2 are there. 2 into, then NO. NO enthalpy formation, how much is given? 90. 90. Then minus, then enthalpy of reactants. Enthalpy of reactants, what are this? N2O. N2O, how much is there? Sorry, 82. So minus 82. Then here 180. 180 minus 82. 180 minus 82. 82. How much you can get? 98. So 98 kilojoules per mole is the answer. Clear? So this is the answer for this question. Understand all of you? So this is the second question in this session. Then to the third question, all of you. So note it. So ఏం చేయాలి question లో? So enthalpy of products minus enthalpy of reactants have to take. Enthalpy of products minus enthalpy of reactants have to take. So products are NO. So how many moles are there? 2 moles. So you have to multiply, must be with 2. 2 into, then NO formation, how much given? 90. 2 into 90 minus enthalpy of reactants. Enthalpy of reactants, what will be there? N2O. So N2O, how much is given? 82. Some members, they have a doubt here. That is oxygen in case. Sir, oxygen value enduku teeskoledu? Oxygen standard enthalpy value 0. So this is the constituent element. It is a thermodynamically stable. So that's what need not to take O2, N2, H2, carbon, such type of. Clear all of you? Right. So note that. Next question we'll see. Next question. Come to the next question. If 92 grams of, question number 3, if 92 grams of sodium reacts with water, sodium reacts with water in open vessel, open vessel at 300 kelvins, what is the value of work done? What is the value of work done? What is the value of work done? That is the question. Assume ideal nature of the gaseous products. So ఎందులో మెన్షన్ చేశాడు? assume ideal nature of gaseous products. That means, sir, in the chemical reaction, whatever the products, gaseous products are formed, that are present in the ideal behavior. Then this is a question they're asking in the 2022 July 18th అడిగిన క్వశ్చన్ మైది. July 18th EAPCET లో అడిగిన క్వశ్చన్. Then options, look at. So 0, then option B, that is minus 2494 joules, 0.2 joules. then C minus 4988.4 joules, then D minus 9976.8 joules. So observe the question carefully. Observe the question carefully. So these are the options. Observe it. The value of work done. The value of work done they're asking. So work done by the gas. So here actually what happens, sodium reacts with water. So Na, when it is reaction with H2O, the 2 moles of Na in case 2 moles of H2O when it is reaction with that, the 2 moles of NaOH will be formed, 2 moles of NaOH will be formed, plus hydrogen gas releases. So this gas you have to take is as ideal behavior they're asking. So in case here, in case when it is present in the grams lo undanukondi, 2 into 23 atomic mass of sodium, so 46 grams of sodium can releases how many moles of hydrogen? So only 1 mole of hydrogen, right? But in the question lo ganaka meer observe cheste, so that is 92 grams of sodium. 92 grams of sodium kanaka తీసుకుంటే 92 grams, double the number, 46 ki double. So ikkada hydrogen gas kuda 2 moles avutundi. 2 moles of gas avutundi. 2 moles of H2 gas avutundi, right? Work done by the system, work done by the expansion of gas you have to take, by the gas you have to take minus P into delta V have to take, right? Minus P into delta V. Sir, P into delta V according to PV equals to nRT, ideal gas equation అని చెప్పాడు కాబట్టి PV equals to nRT. Then P delta V అయినప్పుడు, P delta V అయితే then delta n RT అని తీసుకోవచ్చా? Then delta n, sir, RT can take delta n RT. So ఈ delta n RT వాల్యూని కనుక మనం ఫైండ్ అవుట్ చేస్తే then P into delta V కి ఈక్వల్ అవుతుంది అది. So then in case if you take delta n value, so delta n value, so from this delta n value, then that is delta n, that is P delta V equals to delta n RT. Delta n value e reaction lo, it is solid, then it is liquid, then this is also liquid, then this is only gas, right? Delta n value emutundi, delta n equals to 2 moles. So why? Because for the 92 grams 2 moles will be formed. So number of moles, 2 moles of gas, then reactants are 0, so you have to take it as delta n2. So delta n value 2 into R value, so R value what you have to take here, sir, it is work, so that's what you have to take 8.314 joules. Then into temperature how much is given? So 300 kelvins are given. So look at, multiply all this, so 600, so 600 into 8.314. So when it is multiplied with this, then you can get the answer for this is, the answer for this is, sir, 409.88.4 joules you can get. దాన్ని kilojoules లో కన్వర్ట్ చేసుకుంటే then point which will come to there, sir, 4.9884 kilojoules per mole you can get. So but here the joules only will be there. So ఇది delta n value. So మనకు కావాల్సింది work done. So work done is equals to minus P delta V, right? So P delta V value got it. So minus, then what will be there? 4988.4 joules. So minus లో ఉంది ఆన్సర్. సో నెగటివ్ లో ఉంది, ఆప్షన్స్ లో నెగటివ్ లో ఉంది. ఎందుకు నెగటివ్ లో ఉంది? సో వర్క్ డన్ బై ద సిస్టమ్, వర్క్ డన్ బై ద సిస్టమ్ ఎలా రిప్రజెంట్ చేస్తాం? సో నెగటివ్, వర్క్ డన్ ఆన్ ద సిస్టమ్ పాజిటివ్. సో దిస్ ఈస్ ద ఆన్సర్ ఫర్ దట్. సో నోట్ ద క్వశ్చన్ of you carefully. We'll go for the next question. Yes, come to the next question. Come to the next question, my dear students. Yes, look at the enthalpy formation of this is the question number 4, I think so. Enthalpy formation of CO, CO2 or CO2 or minus 110, minus 393 kilojoules mole inverse respectively. The enthalpy of combustion of CO, the enthalpy of combustion of CO is in kilojoules per mole is, that is the question actually. Then options, look at minus 283.0 kilojoules, B minus 110.5, then C 504, then D minus 221.2 kilojoules, like this is given. The enthalpy formation of CO2, enthalpy formation of CO2 that are given minus 110, minus 393 kilojoules mole inverse respectively. Both values of formation is given. The formation of CO, nothing but how to take, man? The carbon plus half O2 gives rise to, then CO, then delta H value, how much is there? So minus 110 kilojoules, right? Next, the CO2 nothing but how can you take formation of CO2? C plus O2 gives rise to CO2. Then how can you say these are the formation? Formation nothing but 1 mole of compound is formed from their constituent elements, nothing but that is enthalpy of formation. Enthalpy of formation of both compounds are given, that is, then here minus 393 kilojoules per mole. Clear? Then what they're asking in the question, combustion of CO. So combustion of CO, what will be there? CO plus half O2 gives rise to CO2. This is the question. So the combustion, enthalpy of combustion, దీనికి ఎంత వాల్యూ వస్తుంది? That is the question. So delta H value find out చేయాలి. సో డెల్టా H value find out చేయాలి అంటే, సో ఇది ఎలా find out చేయాలి? సో ఇక్కడ ప్రొడక్ట్స్ ఉన్నాయి, ఇక్కడ రియాక్టెంట్స్. సో ఈ రెండు ఈక్వేషన్స్ని బేస్ చేసుకుని ఈ ఈక్వేషన్ వచ్చేలాగా చేయాలి. సో CO2 సెకండ్ ఈక్వేషన్లో CO2 యాజ్ యూజువల్గా ప్రోడక్ట్ సైడ్ ఉన్నది. సో ఫస్ట్ ఈక్వేషన్లో కార్బన్ మొనాక్సైడ్ ఇక్కడ ప్రోడక్ట్ సైడ్ ఉన్నది, బట్ ఇందులో రియాక్టెంట్ సైడ్ ఉన్నది. సో ఇప్పుడు దీనికి ఎంథాల్పీ డెల్టా HC రావాలి అంటే, సో యూ హ్యావ్ టు టేక్ యాక్చువల్లీ ద కంబషన్ రియాక్షన్స్ మెయిన్గా. సరే, ఎంథాల్పీస్ ఆఫ్ రియాక్టెంట్స్ మైనస్ ఎంథాల్పీస్ ఆఫ్ ప్రోడక్ట్స్ హ్యావ్ టు టేక్ రివర్స్ తీసుకోవాలి. సరే, ఎంథాల్పీస్ ఆఫ్ రియాక్టెంట్స్ వాట్ విల్ బి దేర్? CO2. సో దట్ ఈస్ minus 393, then minus, Then enthalpies of products what will be there? CO ఎంత ఉంది? So minus of minus, then 110 kilojoules, right? So minus 393, so minus into minus plus, so 11 plus 110, so 393 లో 110 తీసేసారు, 3 then 8 then 283 can get. సో నెగటివ్ వాల్యూ హయ్యర్ వాల్యూ ఉంది కాబట్టి సో minus 283, so minus 283.0 kilojoules per mole. So you can get the answer like this. Understand all of you? Once again look at carefully. So this is equation number 1, then this is equation number 2. సో ఈ ఈక్వేషన్లో ప్రోడక్ట్ సైడ్ CO2 ఉంది, దెన్ ఈ ఈక్వేషన్లో రియాక్టెంట్ సైడ్ CO ఉంది, రియాక్టెంట్ సైడ్ CO ఉంది. సో ఇక్కడ యాక్చువల్గా కంబషన్ రియాక్షన్ అన్నప్పుడు కంబషన్కి, అదే ఫార్మేషన్కి అయితే ఎంథాల్పీస్ ఆఫ్ ప్రోడక్ట్స్ మైనస్ రియాక్టెంట్స్ తీసుకోవాలి. ఎంథాల్పీ ఆఫ్ ఫార్మేషన్ అని అడిగినా, ఎంథాల్పీ ఆఫ్ చేంజ్ ఆఫ్ ద రియాక్షన్ అని అడిగినా, సార్ ప్రోడక్ట్స్ మైనస్ రియాక్టెంట్స్ తీసుకోవాలి. కంబషన్కి మాత్రమే reactants minus products తీసుకోవాలి. Clear? Understand? Yes, note the question carefully. So Vikas said hi. So hi my dear students. So look at one more important question. One more important question. So that is question number 5. Question number 5. For the reaction at 25 degrees Celsius. For the reaction at 25 degrees Celsius, X2O4 gives rise to 2XO2. Sir, here this is mentioned as a liquid, this is mentioned as a gas, remember. Then delta U and delta S. Delta U, change in the internal energy, delta S, change in the entropy, are 2.1 kilocalories and 20 calories per Kelvin entropy units respectively. What is delta H for the reaction? What is delta G for the reaction? Delta G for the reaction. At the same temperature. Delta G find out చేయమన్నాడు. R valued is equals to 2 calories mole inverse Kelvin inverse ఇది ఇచ్చాడు ఆన్సర్ లో. ఆప్షన్స్ చూడండి. ఆప్షన్ 1 that is minus 2.67 calories, that is kilocalories, then plus 2.67 kilocalories, then 3 minus 1.67 kilocalories, then fourth one 3.67, that is plus 3.67 kilocalories. These are the questions. So మీరు క్వశ్చన్ ని అబ్జర్వ్ చేస్తే, సో ఇందులో డెల్టా యూ వాల్యూస్ అండ్ డెల్టా ఎస్ వాల్యూస్ బోత్ ఆర్ గివెన్, బట్ దేర్ ఆస్కింగ్ డెల్టా జీ. యాక్చువల్గా డెల్టా జీ ఫైండ్ అవుట్ చేయాలి అంటే డెల్టా హెచ్ మైనస్ టీ డెల్టా ఎస్ తీసుకోవాలి. అంటే ఇందులో డెల్టా హెచ్ వాల్యూ లేదు, మనకి ఇచ్చిన ఇన్ఫర్మేషన్లో డెల్టా హెచ్ వాల్యూ లేదు. So ఇచ్చిన ఈక్వేషన్ ఇది. So this is the equation. So ఈ ఈక్వేషన్ కి డెల్టా హెచ్ వాల్యూ ఫైండ్ అవుట్ చేయాలి అంటే లుక్ ఎట్ డెల్టా హెచ్ ఈక్వల్స్ టు డెల్టా యు minus delta n RT have to take. So delta n gaseous reactants. Products are gaseous reactants. So delta n value find out cheyalante number of moles of products minus number of moles of reactants have to take. So gaseous products minus gaseous reactants. So gaseous products, how many are there? 2. The reactants are liquid, so 0. Then delta n value you can get 2. Delta n value ఎంత వస్తుంది? 2 వస్తుంది. Okay, delta u value ఎంత ఇచ్చారు మా? Delta u value 2.1 kilocalories is mentioned. So that you have to convert it into the calories. Then when it is multiplied with 1000, you can get so 2100 calories minus delta n value is 2. So into R value also 2. Then temperature. Temperature, how much is mentioned? 25 degrees. 25 degrees nothing but that is 298 kelvins. 298 kelvins. So delta n value 298 kelvins. So then, so 4 into then 298. So 2100 then minus 4 into 298. 298 kelvins. Here you can get delta H value. Then what you have to find out? Delta Z. So delta Z find out cheyali ante delta Z equals to delta H minus then T into delta S you have to take. T into delta S. Delta H value how much we got? So multiply with that. Then subtract the value 2100. Yes, substitute the values all. So delta H value, how much is there? Delta H value, so that is 2100 minus 4 into 298. 4 into 298. Then this is totally delta H minus temperature again 298 kelvins you have to take. So into delta S value, how much is there, man? Delta S value, that is 20 calories, multiply with 20. Then final answer you can get it is, so that is 2670 calories per mole you can get. దీన్ని క్యాలరీస్ లో కన్వర్ట్ చేస్తే 2.67 kilocalories per mole. So this is the answer. Sir, look at my dear students, the daily these are the previous year questions we are discussing from every chapter. So daily at least 10 or 5 or 10 questions we'll discuss. Today the less time is there, I have to go to the college, so that's what I will complete the session now itself. Then every day you have to join in the live session. Then those are preparing for the JEE mains examination and EAPCET examination, better to listen my classes the morning 6 to 7 and evening 7 to 8. Thank you.